Welcome back to our journey through chaos. Today, we're looking at one of nature's best-kept secrets, the hidden energy in phase changes. Think about a glass of ice water. You're adding heat from the room, yet the temperature doesn't budge from zero. Where's that energy going? In physics, we call this the hidden energy. It's the energy that transforms matter without raising its temperature. Usually, adding heat makes atoms jiggle faster, raising the temperature. But during a phase change, we see a plateau. The thermometer stops climbing. Inside the ice, molecules are locked in a rigid lattice. To turn into a liquid, those bonds must be broken. The heat you add isn't going into speed, it's going into work. It's literally prying the molecules apart. This is latent heat. Latent comes from the Latin word for hidden. It's the energy required to change the state of a substance. For water, it takes 334 joules of energy to melt just 1 gram of ice. That's enough energy to lift that gram 34 kilometers into the air. But what happens when we go from liquid to gas? The stakes get even higher. As water boils, the temperature stays at exactly 100 degrees. No matter how high you turn up the flame, the water won't get hotter until it's all steam. To become a gas, molecules must completely escape the pull of their neighbors. This requires a massive surge of energy. The latent heat of vaporization for water is over 2,200 joules per gram. That's nearly 7 times the energy needed to melt ice. That energy isn't gone. It's stored in the steam. That's why steam burns are often more severe than boiling water burns. It carries that extra hidden heat. When steam condenses back into water, it releases all that energy. This cycle is what drives our weather and powers giant steam turbines. Phase changes remind us that energy isn't always about motion. Sometimes it's about the structure of matter itself. So next time you see a pot of boiling water, remember, the temperature is standing still, but the atoms are working harder than ever. Entropy, energy, and the hidden dance of atoms. Thermodynamics shows us that even in a glass of ice water, there's a magnificent logic at play. I'm James, and this is Physics 101. Join me for the next lesson as we trick heat into doing work with heat engines. Master the chaos.